Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy, and for today's video, I am going to discuss solving proportions with variables. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. In my previous video, we discussed already about the definition of ratio and proportion. If you still remember, a ratio is a comparison of two quantities. Let's say you have these pictures. What is the ratio of the number of boys to the number of pencils? The answer is 3:11. There are 3 boys and 11 pencils. Let's try another problem. What is the ratio of the number of apple trees to the number of apples? The answer is 2:12. Remember that ratio can also be expressed in lowest term, meaning the ratio 2:12 is also the same as 1:6. Okay, if we apply or if we reduce ratio in its lowest term. In our previous video, we also discussed and defined proportion. When we say proportion, it is an equation that states two ratios are equal. Also, proportion has two parts. The first part is what we call the extremes, and the other part is called the means. Also, take note that the product of the extreme is equal to the product of the means. So when you multiply the extremes, we have 3 multiplied to 2, the answer is 6. Also, that is equal to the means when you get its product. So 6 times 1, the answer is 6. So this means this is an example of a true proportion. Okay, let's have some more examples. Let's try to read the proportion. How do we read this? That is simply 1:15 as to x is to 625. In the proportion A all over B is equal to C all over D, the products of A times D and B times C are called cross products. You can solve a proportion for a missing value by using cross product property. So in a proportion, cross products are equal. So just like what I've said earlier, the product of the means is equal to the product of the extremes. Here are some rules in solving proportions with variables. Number 1, we have to apply cross multiply or cross product. Number 2, divide both sides by the number connected to the variables. And number 3, check the answer to see if it makes a true proportion. Let's try to solve problem number 1. Suppose we're going to solve for the value of m. So we have 3 all over 9 is equal to 5 all over m. Step number 1, we will apply cross product. So we have 3 multiplied to m is equal to 5 times 9. Okay, so 3 times 5, that is 3m, is equal to 5 times 9, that is equal to 45. Next is we will divide both sides of the equation by the number connected to the variable, and that is 3. So we will divide both sides by 3. Then m is equal to 45 all over 3. The answer is 15. Okay, now our last step is to check whether this value will make a true proportion. So we now have 3 all over 9 is equal to 5 all over m, where the value of m is 15. So 3 times 15 is equal to 9 multiplied to 5. So 3 times 15, that is 45, is equal to 9 times 5, 45, meaning m is equal to 15 makes this proportion true. Let's try to solve problem number 2. Solve the proportion 6 all over y minus 3 is equal to 2 all over 7. So we're going to find the value of y to make this a true proportion. So again, our first step is to apply cross product property. So meaning we're going to multiply 6 and 7. So 6 multiplied to 7 is equal to, we have here 2 times y minus 3. Then we will remove this parenthesis by applying multiplication. So 6 times 7, that is 42, is equal to 2 times y minus 3. So this time we will apply distributive property. So 2 times y, that is 2y, and 2 times negative 3, we have negative 6. After this, we're going to add both sides of the equation by positive 6. So 42 plus 6, that is 48, is equal to, bring down to y, then negative 6 plus 6, that is 0. These two are examples of zero pair, so we can also cancel this out. Now what is left is we have 48 is equal to 2y. Then we divide both sides of the equation by 2. Okay, so we now have y is equal to 48 divided by 2. The answer is 24. So this time, we will have to prove that this value we obtain here will produce a true proportion in the original equation. So we have 6 all over y minus 3 is equal to 2 all over 7. So we plug in 24 here. So we have 6 all over 24 minus 3 is equal to 2 all over 7. So 6 all over 24 minus 3, that is 21, is equal to 2 all over 7. Then, multiply 6 times 7, multiply to 2 times 21. 6 times 7, that is 42, is equal to 2 times 21, that is also 42. Meaning, 24 is a solution because it gives a true proportion. Let's solve problem number 3. So if we're going to find the value of y in negative 5 all over 2 is equal to y all over 8. So our first step is we will apply cross product or cross multiplication property. So we have negative 5 multiplied to 8 is equal to 2 times y. Then we have to get rid of this parenthesis by simply multiplying negative 5 and 8. The answer is negative 40. Remember, in multiplying sign numbers, if we have two unlike signs, the product is negative. And we have 2 times y, that is 2y. Next to that is we will divide both sides of the equation by 2. Now, we have y is equal to negative 40 divided by 2. The answer is negative 20. Remember, in dividing unlike sign, it's the same with multiplication rule. So if that's unlike sign, the quotient here is negative. So y now is equal to negative 20. After this, we have to check if this will produce a true proportion by substituting the value we obtained here in our original equation. So from negative 5 all over 2 is equal to the value of y we obtained, that is negative 20 all over 8. So apply cross product. We have negative 5 multiplied to 8 is equal to 2 times negative 20. Then, that's negative 5 times 8. The product is negative 40 is equal to 2 times negative 20. That is also negative 40. So, it produces true proportions since we have here negative 40 is equal to negative 40. Therefore, y is equal to negative 20 is a solution. Let's try to proceed in solving example number 4. Suppose we are asked to solve for the proportion g plus 3 all over 5 is equal to 7 all over 4. Notice that this example is almost the same in example number 3 we have earlier. Now, let's try to solve for the value of g to make this proportion equal. Okay, so step number 1, we will apply cross product. So we have 4 multiplied to g plus 3 is equal to the product of 5 multiplied to 7. Next is, we will apply distributive property. So 4 times g, that is 4g plus 4 times 3, that is 12, is equal to 5 times 7, that is 35. Next to that is we will apply subtraction property of equality, meaning we're going to subtract both sides of the equation by negative 12. So this is now 4g, then 12 plus negative 12, that is 0. Okay, so we can cancel this out, is equal to 35 minus 12, that is equal to 23. Then divide both sides of the equation by 4. So the value of g now is equal to 23 all over 4, or in decimal, that is equal to 5.75. Now let's try to check if this will provide a true solution. So we will plug in the value of g here. So that is, I'm going to use the fraction. So that's 23 all over 4 plus 3 all over 5 is equal to 7 all over 4. So we will apply cross product. So that's 4 multiplied to 23 all over 4 plus 3 is equal to 7 times 5. So when you multiply this, 4 times 23 all over 4, we can cancel 4. That is what is left is 23 plus 4 times 3, we have 12, is equal to 7 times 5, that is 35. Then we add 23 and 12, that is 35, is equal to 35. So meaning to say that the value of g we have here, 23 all over 24, is a solution to our proportion. And finally, for our last example, example number 5, I want you to get a piece of paper and pencil. Try to solve for the value of x in the proportion x plus 2 all over 5 is equal to 3 all over 8. If you have already your answer, please comment it down in our comment box below. So that's all for now, and I hope you learned something new in our lesson for today. Goodbye!